All right, welcome. For those that are coming in, if you can take a seat, and if you can come, I think we're expecting probably another 30, 40 people, so if you can kind of push towards the windows, we'd appreciate it. I want to welcome everyone out to this Northwest Robotics Alliance event. This is our second event with the theme of Generative AI for Robotics. Thanks again for joining us. It's good to have another near sold out event and to see the interest in connecting with one another around this important topic in the Northwest. About 5 years ago, I went to an event called the Future of Robotics in Seattle. And I was actually really let down. We didn't really talk about the future. It was a couple sponsors that shared some things. I did meet one of our directors for hardware, and that was great. But I just there wasn't much about the future. And tonight we're here to actually talk about the future of robotics and generative AI being a key theme relevant to the future, and to keep building the Northwest robotics community. I want to thank our leadership team, Asim at Madrona and Firdos from Cascadia and Cascadia for helping co-organize this event. I'm Jeff Dance. I'm the CEO, founder of Fresh Consulting, who's also one of the co-founders of the Alliance. Also want to thank our team, specifically James, Kurt, and Anna, for your help in kind of organizing this event. It was great to have as many tickets as we could offer be taken up, so we should expect some more people here tonight. Just as a way of logistics, if you need to use the restroom, it's in the main hall out there, so at some point this evening, if you need to take a break, that's where it is. For the agenda today, we're going to kick off with a keynote on Generative AI for Robotics by Tim Chung. Then we're going to move to a panel on the same theme, led by Asim Datar, and he'll introduce the panelists. We're going to take a quick break after that for about 10 minutes. If you want to grab a drink before some of the food gets here a little later, we'll do that, and then we'll go to the second half of the agenda for today. Last time we met, I think it was just a couple months ago at Madrona's Create 33 facility, I actually spoke and I was talking about the future of human-robot interaction. And I shared a little bit on the topic of generative AI and robotics, and I selfishly was really hoping that we could have this be a topic for the next event. And the team agreed. And one of the things I talked about was how the future of robotics is together. The history of robotics historically has been apart, where they've been siloed, but really the future is together. And having humans and robots sort of working together in an integrated fashion in the loop, we're seeing a lot of movement in this space as we think about the future. And I shared sort of some predictions last time we met, and some of those was like, hey, the speed of everything happening in generative AI on the backbone of the cloud is really a rising tide for robotics. And I think anyone who's been in the robotics space has never really moved as fast as we would have liked. Technology has been moving fast, but the adoption of robotics in certain verticals has moved quickly, but generally has seemed slower for those that have been really passionate about the forthcoming advancements. But now we really are seeing this opportunity for accelerating human-robot interaction. And we talked about all the things that generative AI could offer, generating environments and language and context and code and steps and reasoning and tasks and parts and size and distance. I shared a few examples of some of the big libraries that are out there, and talking about on the back end of that, we have an acceleration of the ability to perceive, understand, reason, communicate, and collaborate. And because of that, natural language, natural tasks, a more natural ability for robots to overcome Moravec's law and integrate and truly work in the natural environment. There's this position to have a lot more natural integration today. These are some of the things I shared as we were talking about generative AI and robotics, really accelerating speed, which is the last great competitive advantage in technology. I would say those are predictions, and I would pose the question, is that true? And I think tonight we're going to find out. We're going to start to find out if that is true. With that, I want to welcome Tim Chung and give a quick intro to him before he comes up to speak. Dr. Tim Chung joined Microsoft last year in March of 2022 as their general manager for Autonomy and Robotics, where he leads next generation technology solutions for both commercial and government applications. I'm excited for his leadership, specifically in our backyard at Microsoft with his experience. Prior to Microsoft, he served as a key leader and program manager at DARPA, where he led the Swarm-Enabled Tactics Program and the DARPA Subterranean Challenge. And then previously, he served as an assistant professor at the Naval Postgraduate School and director of the Advanced Robotic Systems Engineering Laboratory. So in addition to a mechanical and aerospace engineering degree from Cornell, he's got a master's degree and a PhD in mechanical engineering from Caltech. So he's got lots of great depth, lots of great experience. Excited to have him here in the Northwest. He actually lives close to me, so we recently met up. He has a beautiful family. And let's welcome him up to the stage to talk about generative AI for robotics.
No, appreciate it. All right, good to go. Yeah, I think we're good. All right. Thank you so much. I really appreciate the opportunity to come and join with you all here. I've been super excited about the energy that I'm already feeling in this room and the energy that's surrounding generative AI and the future of robotics. And so it's a great opportunity to be here. I think the whole story here, like Jeff kind of set it up, is that, what is that future of robotics and what's the role of generative AI? And I think it's such an exciting time to be a roboticist because we're on that cusp of next generation AI enabling next generation robotics. And so with that, I'm eager to share some thoughts and perspectives on how we're thinking about it at Microsoft and where we think the robotics community writ large will be able to go. And so, as Jeff mentioned, I'll just briefly highlight, my name's Tim Chung. I joined Microsoft not too long ago, and really it was on the back of my experiences, for example, at DARPA, where I led a number of programs, whether it was trying to get 200 drones and rovers going and serving urban operations, to conducting search and rescue missions in underground caves and mines, for example. And how do we get robots to go and operate in those kind of austere locations? As well as prior work as a professor, where I had the great fortune of working with our junior officers in the Navy and Marine Corps. So a lot of these lessons, I think, come from those types of experiences spanning both academia, working with large companies and small startup companies, all the way to now being at a large company in support of a kind of a robotic startup within Microsoft. And so I want to share a perspective that I think will set the framework, the backdrop for how we can think about robotics and the role of generative AI. So I think in the context, we all are familiar with the evolution of robotics going from the single robot scenarios that are going off and doing those single purpose tasks, being able to then grow into teams of robots that are now able to take advantage of a little bit more scale to do and accomplish greater, more interesting things. But of course, really where we think things will go is when you have these fleets of robots. We call them federations of robots. And it could be collections of robots from different vendors. Maybe they're robots across different domains, so air, ground, sea, underground, as the case may be. But it's that collection of how we get these robots to coordinate with one another. What does it mean to have a society of robots, if you will? And what are the kind of the social norms that go along with robots and the language that we use to interoperate across them? So this is one perspective, one angle, one axis, if you will. Here's another one. And this is where these robots live, operate, and contribute to operations. And so we typically understand that robots are in closed world environments. This is where there's a lot of structure. There might be some safety zones or keep out zones or rules of the road that allow for robots to operate in these isolated environments. But it's an awesome time to be a robotics person because we're seeing robots now enter these congested environments where they have to operate near, with, among humans and other challenging environments. And so whether it's physically constrained or maybe socially constrained robots, we're seeing these robots operate in that congested regime, which is great. There's also another opportunity where they're operating in highly unstructured, highly dynamic environments where the infrastructure not only might be ephemeral, but might not even be there to begin with. It could be that you have adversity due to weather or terrain or an actual scenario like active shooter or some other kind of challenging environment that these robots are now being increasingly called upon to act. And so we kind of bring these two together. I'm a big fan of graphs, and we look at the vertical and horizontal axis here, and it's immediate, perhaps to many in this audience as enthusiasts for robotics, that a lot of our attention has been in that bottom left corner. And we've done great things for robotics, both in our factories, in manufacturing and supply chain, even on our streets. But I definitely think that to kind of address where the puck is going, it's this upper right that offers up additional opportunity to be able to advance technology to that next step level, to that next plateau of robotics capabilities. And so I think from a perspective for Microsoft, but I'd say the robotics community writ large, there's a really fantastic opportunity to have near-term impact in this bottom left, while also far-reaching and consequential, very compelling impact in the upper right. And so I'd say Microsoft is eager to collaborate across the community, across our commercial and industry and academic partners, across schools and universities in general, to bring forth a number of technologies that will help us accelerate to this upper right. That spans everything from safety and security to scale and interoperability. And those are kind of the technologies that I'd love to engage with this community and the broader Northwest robotics arena to be able to make that a reality. And so what's exciting about generative AI is it takes this chart and it applies a drift to the right, in fact, a drift to the upper right, by providing generalizable capabilities thanks to AI. And that's really what's exciting about this, is that even if there was this natural progression from bottom left to upper right, generative AI is helping accelerate that trend. And that speed, as Jeff mentioned, is the competitive advantage that we're all hoping to capitalize on. And so here's some examples of those generalizable capabilities, right? It could be, for example, this is a Microsoft Florence model for vision plus language that's allowing us to understand dynamic environments through vision. So what can you do when you have hyperscale AI offering you understanding, whether it's through captioning of videos or summarization of video feeds? Or on the other hand, and so one of the groups here for later on the panel, Ashish, I know you're right there somewhere. You know, this team, some of you may be familiar with the ChatGPT for Robotics paper that came out. And this is really harnessing ChatGPT to go and now provide a different mechanism for interfacing and working with robots. And so natural language as a mechanism for controlling, but not just controlling, but really having a more meaningful interaction across the board with robotic systems. So this is, again, pushing us towards that upper right trend. But it doesn't stop there. And I think that's one of the things I'd love to convey this evening, is that robotics is now growing not just a collection of actuators or sensors or compute boards, but a holistic end-to-end system capability. And it's really where the integration combines with interoperability that I think we get that acceleration that we're all really deeply interested in. And so let me give you a couple of additional examples of generative AI having that kind of holistic end-to-end impact. So many of you may be familiar with GitHub Copilot or some variant of a code assistant. But this is one example where not only are we the tinkerers and the makers and the builders and the developers, but imagine if you can now open the aperture of who can be a roboticist, right? So now you're no longer necessarily a quote unquote classically trained roboticist or a hacker maker. You're now able to open up a whole new genre of developers when you have an AI co-pilot assisting you with your code development. And so this broadens what kind of technologies we can bring, how quickly we can get them implemented and integrated into our systems. What's another example? This is where robotics interacting and understanding the world that they operate in is going to be absolutely critical. And so how does generative AI help us with something like this? This is an example, if I can get to it. I think it was maybe showing. There we go. So this is a project at Microsoft called Planetary Computer. Let's see if I can get that to go. So this is a catalog, a massive catalog of geospatial data collected from NASA satellites, from NOAA satellites across the European Union, et cetera, to now offer up multimodal sensing data, Earth observation data, in the context of sustainability and our commitment to sustainability. And you can see it's from all sorts, from SAR data to thermal imaging to firefighting data sets. What could you do once you had these data? There's no shortage of data out there. We'd love to have more, of course. But what could you do if you could apply co-pilots to this type of an arena? And how could it make our robots more capable going forward? And so imagine the planetary computer co-pilot, where now you can take advantage of language to interact with this massive amount of data. And just imagine how you would wire this up with the sets of robots that you might want to go for agriculture, for firefighting, for other types of applications. And so here you can go ahead and just type in things like, hey, can you show me the impact of flooding from a disaster response perspective? And can you interact with these data sets, for example, identifying where the buildings are located to overlay and now have a back and forth conversation about the data from a geospatial perspective. But this is just the front end to anything we might want to use for our robotic systems. So for, again, disaster response, or maybe for insurance assessments after disasters to do with drone footage or what have you. This is now unlocking that regime of access to data to our robotics community as well. And so this is hopefully trying to motivate the fact that where AI resides and what it unlocks is transformative for robotics. And this is what's really exciting, and I hope to have that further conversation with y'all this afternoon, is that robotics, I think historically you might have thought, hey, it lives at the edge because, hey, that's where the data is being collected. That's true, and there's a lot of work that has been done and still needs to be done to enhance the ability to leverage AI at the edge. That's great. I hope and encourage all of us to continue doing that. I think what we highlighted here is that the cloud is an accelerant to a lot of these AI technologies, whether it's being able to process large volumes of data, whether it's the ability to perform analytics or generate new forms of data, but the cloud is incredibly empowering. But there's also this connective tissue in between, whether that's 5G as a technology, whether that's Wi-Fi, of course, but including satellite communications and low Earth capable satellite constellations to connect these teams of robots with the cloud or other types of resources. And at the end of the day, I'm really excited about where we're interested in is at the intelligent command and control or intelligent orchestration layer. Because as was mentioned before, it's when humans meet robots, meet AI, that things get incredibly exciting. And that's exactly where we're positioning Microsoft to be able to contribute, again, back to the robotics industry and community. And so ChatGPT, co-pilots across the board, and we have quite a number of those. GitHub Copilot, as I already mentioned. And I think it's that interface that's really going to help accelerate things in general. So I'm going to give you an example of some of the things we've been working on at that layer where you're dealing with command and control or orchestration of robotic systems. And so one example of using ChatGPT is in mission plan generation. The ability to take high level, here's what I would love to do with my robots, turn that through conversation with ChatGPT into a mission plan, be able to identify and speak the language of your robots through conversation. And so this is an example where using ChatGPT, we're able to generate this JSON formatted file, which is what the machine speaks to understand what kind of mission to conduct. We're able to pass this along. In our case, there was a human involved, and that's one of our core commitments, is to always have some notion of supervisory level of understanding for where human decision and agency is relevant. And so being able to pass this along for a human to say, yeah, that sounds like an appropriate search mission or appropriate mapping mission, and the go, no-go criteria is met, and he or she is able to deploy to that aerial robot, for example. And so just to kind of give you a little bit more color of what that looked like, you might have a mission plan. This is typical, right? You go out to the field, you've got a notional plan or at least a sketch of a plan. No plan ever survives first contact with the real world, but nevertheless, you might use this type of a framework. We would generate something like a JSON file in this particular case for this particular type of robot and be able to deploy it and run with it. Now, what was really exciting about this particular field experiment, which I'll show you here, was that we were able to sit down with different people and different operations. We were out in the middle of not necessarily nowhere, but a place where we were able to bring our own little Starlink terminal and communicate back through Starlink to Azure to connect to Azure OpenAI. And this was us being able to rapidly iterate and be able to define missions that you might not necessarily have been able to do as expediently as before. And so the fun anecdote that's not shown here is that we turned around, there was another drone small startup company behind us, and we said, hey, have you tried something like this before? And they're like, no, we usually use it to help us write our reports and papers, but nothing like designing mission plans. And so just over a matter of iterating with ChatGPT, totally different drone, totally different mission plan format, gave it a couple of examples. Can you draw me a figure 8 pattern, go fly that pattern? And we're able to do that in about 45 minutes, right? And so this is now no longer about having interface specification documents, laboriously going through that process of iterating in that context, having your spec document change on you and then having to go fix that. This is now a conversation that you can have to rapidly integrate. And so I really liked Jeff's list. Here are a couple of other questions I'm going to pile on here. What else can we do when we're talking about large language models? And it spans from the design phase all the way to let's go operate and make use of these things in the wild. And so everything from understanding the attributes and the capabilities of robots. Wouldn't it be great if I could interrogate a robot kind of like at a job interview? Tell me what's on your resume and what you're capable of doing. Well, that level of understanding and introspection is right at the cusp of what we're capable of doing with these large language models. Understanding, what does it mean to have safety guardrails and understanding the regulatory environment around these robots. I think that's another place for large language models to be able to rapidly aggregate that information and provide that to developers and operators alike. And so I'll leave it with this and say, in addition to the conversations that you'll hear this evening, I'm really excited about what's next. And I think the understanding of the physical world, where there's highly multimodal information, understanding the nature of space and time, so physical environment plus the dynamics of the world that we live in, is, I think, really going to be pretty fascinating. And we can see how far both large language models but large multimodal models will certainly take us. The Copilot, I really love, not just because it's Microsoft, but also because the idea that there's always a human, and this is AI, enabling us to do more. And I think that aligns with both Microsoft's mission to empower every person and organization to achieve more, but also I think it's an opportunity for us to highlight the societal benefits that we hope we all hope will be realized with AI and robotics. And then finally, I really think that a cool place for robotics and for generative AI is not only being able to assess the quality of the AI, but actually the quality of the autonomy using that AI. So in other words, how do we develop the tests for our autonomy use cases using generative AI as the tool that's going to help us write the test, not just help us write the answers. And so finally, I think the main thing, and I've alluded to it a number of times, is trustworthy AI. I think we're all in agreement in this room that this is where we'd all like to be. And I think the process by which we achieve that, certainly responsible AI, and something that Microsoft has both outwardly and internally made strong commitments to. And so I just wanted to highlight our responsible AI standards and the principles by which we operate and how this translates to responsible robotics as a path forward as well. And so again, really appreciate the opportunity to engage with you all. I think there's going to be incredible amounts of vibrant conversation this evening. Looking forward to engaging in those, and I'm super excited about the opportunity to work with each and every one of you. Thank you very much.
For the next session.
use the other one. Hello? Is it good? Can you folks hear me? Awesome. Hi, everybody. Thanks for coming. My name is Asim Datar, and I'm a partner over at Madrona Ventures, investing in enterprise companies. And then more recently, we're getting super excited about this old but new category called robotics. And it's okay. It's just my wife. Take care of it. So welcome and thanks for coming to our second event. We have an exciting panel today, with our esteemed guests. And I always try to introduce them, and I have an epic fail. So I'm going to stop and not do that. I'll let these folks introduce themselves. So why don't we just talk about, do a quick round of introductions, who you are, what you're working on, and what's exciting in the world of robotics.
Great. Well, thank you, Asim, and thanks for having us. So I'm Ashish Kapoor, CEO of Scale Foundations. So we are in the business of building foundation models for robotics, specifically focusing on aerospace. My background is that until recently, I was heading the Microsoft Research Robotics and Autonomous Systems group, where we partner with Tim and many other folks. I've been doing robotics for more than a decade now. My PhD was in machine learning a couple of decades ago, and I feel very excited that this tidal wave, as was mentioned in the first the presentation, where cloud and foundation models and neural networks. I say without intelligence, a robot is nothing but a fancy collection of parts. And I think we have the opportunity to make it a real robot now.
Hi, I'm Dan Rosenstein. I've been with Microsoft. This is my 25th year contiguous. I work with Tim. I work for Tim. So I basically do what he tells me. All jokes aside, I've been in love with robotics since I was a little kid. I got my master's in robotics and controls just about a decade ago. I've been doing robotics-related work at Microsoft pretty much my entire time, in one way or another. Since I've been excited about robotics since I was a kid, I've been a FIRST coach, mentor, and board member. So if you're not active with FIRST, you should talk to Lila up front, and she can get you active with FIRST. And I'm extremely excited about what we're doing at Microsoft with robotics, building on the work of Ashish and work with Tim as well. Some of the things that I've done recently, a lot of the things that Tim talked about, we worked on together for. So, and we'll talk more about some of the insights and learning there. But anyway, super glad to be here.
I have two of them. Yeah.
Go ahead.
Okay. Hello, everybody. Thank you for having us. My name is Minas Liarokapis. I am the Chief Robotics Scientist of Acumino, and I am also an Associate Professor at the University of Auckland in New Zealand, the other Auckland. I work in robotics the last 12, 13 years, something like that, and I mainly work on robotic grasping, manipulation, and how we can get the robots to be really useful around us in everyday life environments. And I enjoyed a lot your talk.
Awesome. So let's get started with some really simple questions. Tim talked about the left, like moving from the bottom left to the top right. In robotics, one of the things that's always been sort of a challenge is the friction, right? The amount of time it takes to sort of program the robot, start to use it, in structured versus unstructured environments. Like, I'd be curious to hear your perspective on, there's generative AI, and in the world of software, you can see a lot of use cases that are low-hanging fruit. There's customer experience, there's deployments, there's writing code, there's co-pilots. Like, how does life get easier on the robotic side of things with Gen AI? And by the way, I should just open by asking, does life get easier with generative AI?
Yeah, so, I think it's, so generative AI by itself is only useful if you have the ecosystem around it, right? I mean, so think about simple robot, like we are in flying robots, so imagine a drone, right? The amount of effort that it takes you to introduce a very simple AI capability, something like, go and just follow a line on the ground. The amount of engineering that needs to happen to make this thing is incredible. And unless we reduce that friction, it's going to be very hard for people to basically start, building an app ecosystem or an ecosystem where people can go and really, push robotics at the frontier. So in my mind, generative AI is giving you the tools, but your ecosystem needs to be ready to catch it. Otherwise, you will have the same problems. One thing that generative AI is doing is definitely raising the interest level and the excitement around the area. So you might see more and more robots ready to be AI ready, right? As opposed to just a bunch of parts, and then you have to go and figure out your ecosystem of software and what libraries to put in, whether you can even run a neural network on on an edge device and things like those. So when you think about lowering the barrier to entry, of course, generative AI is giving you the set of techniques in AI field, but your robotic ecosystem, the hardware ecosystem needs to be ready as well. And I think generative AI is just one part of the puzzle. Of course, it's helping you accelerate the second part, but a lot needs to happen there as well.
So one of the things that I've seen pretty clearly as I've been working with generative AI with robotics is that I think it's very much facilitating and helping the advancement and acceleration what we're capable to do with robots. Robotics hardware has been moving forward, getting better, and some people say that it hasn't improved over 30 years. We know that's not true. We know there's been advancements there. Robotic software as well on how the robots are controlled, how they do manipulation, how they sense their environments has gotten better as well. What generative AI is doing is it's created what I consider a cataclysmic leap in that it is really good at doing domain translation between different textual information. And because of that, it allows for human intent to robot intent to be done much easier. The example that Tim used of being able to plan a mission with somebody who is an incidental user, who doesn't necessarily know the details of the robot, the details of how the JSON format it might be structured, but understands a mission, can go and say what they want it to do, and through the text translation and through the generative AI model, get a JSON file that does what they want to do. And the fact that robotic control systems have advanced between mechanical, electrical, and software to the point where you can hand a robot a JSON file in a predetermined format, and it can go drive that path. That's actually the magic. The bridge between humans and robots is the chasm that we are now getting over. And the tool, as Ashish said, the tool of learning how to use generative AI for where it succeeds and where it fails, and we'll probably talk about that later on, is actually the single biggest investment that can and will be made in getting over that chasm.
Gotcha. Anything to add?
Yeah, I completely agree with both of them. Robots, as Ashish said, they are very hard to deploy. Mm-hmm. Very, very hard. They take a lot of time to program them. Do we have this time? No, because the wave is here and we need to ride the wave. I really liked your graph. I am also a very big fan of graphs. But I think that AI needs data. And we need to put more focus on collecting good data. Because robots right now, they are dumb. They're not good. Individual robots, just one robot, doing dexterous manipulation. It's not feasible. By dexterous manipulation, I mean this. Handling the object within the hand. AI is very good at repeating things that we already know. We can train generative AI to follow the style of Da Vinci or the style of another famous inventor or another famous painter and do something. But it builds upon what we already know. It cannot do things from scratch. What we don't know, we don't really know how we do this. If I ask you how you do this, do you know? No, you just do it. So we need to collect big data that will allow robots to be really useful with their grippers and hands in everyday life environments. I agree that we need to go to fleets. I completely agree. I agree that we need to go to societies of robots. But we also need to go to houses. And we are very far away from that. Why? Because we don't have the data. And this is what we are trying to do with Acumino. We are trying to collect the data, and we are trying to empower the people that do the models to build better models. ChatGPT, great, absolutely great. Can it generate trajectories? 0. Not even one. Microsoft demonstrated pick and place. Yes, okay, this is very simple. What about dexterous manipulation? What about assembly? What about, hey robot, can you prepare breakfast? Because I'm very tired. This is the goal. This is what we want to achieve altogether, of course.
So let's talk a little bit about and pull on that thread. Like, are there particular categories of robots, or are there particular environments where Gen AI is sort of going to be directly applicable versus not? I mean, if you look at these categories, and if I'm drawing an analogy by software only, there's a lot of use cases around productivity, around customer experience that are right away solved by Gen AI. Like, what's the parallel in the robotics world? What should you focus on? What should you stay away from?
I'll respond to some of the comments as well that were made. So, when we talk robotics, we seem to, have like this very wide stroke of brush, but I mean, there's a huge spectrum. There are some aspects of robotics which I think are more ready than the others. So specifically dexterous manipulation. And the anecdote I'll share is that when we were incorporating Scale Foundations, I reached out to several of the researchers in the field, just asking the question, do you believe that we are ready for foundation model for robotics, technology-wise? And this is specifically Jitendra Malik at Berkeley, and then he was saying, dexterous manipulation, it's in research field, right? I don't think that we have made significant progress there. But when you talk about things like navigation, things like locomotion within the room or outside the environment, I do believe that the community as a whole has solved that problem and they are ready for disruption in the industry. So I think instead of thinking about robotics as one thing, monolithic thing, it might be better to give a little bit of resolution. Right? I completely agree on dexterous manipulation. We are quite far off. But when we think about, for instance, self-driving car, you already have fleets. Flying robots, you can probably have fleets that can interact with ChatGPT, and the crazy thing is that you can even actually do trajectory generation there. So just having a little bit of nuanced understanding of the domain that you'll go after might provide you a little bit clarity on the questions that we're talking about. And I do agree that in terms of data, that's where robotics has the disadvantage of any other AI field. So if you look at all the other AI fields, speech, natural language, computer vision, we have basically went on the web and mined and collected and curated set of data that you can create these large neural networks which have become the foundation, well, no pun intended, of intelligence. Whereas for robots, that's not the case. A decade ago, when we started robotics group, the biggest challenge was doing any field experiments with robots. It would take a team of 7 to 8 engineers. We'll go outside in the field. We'll probably get flight time of maybe 2 to 3 hours. And of course, at the end of the day, the robots gets broken. And we have 90 days of sunshine in this beautiful state of ours. So it was completely impractical. And to this date, I do believe that having a data set which is I would say, at least 10% of what computer vision or natural language folks have done for robotics will push this field in a manner that, that would be, I think, very significant and very consequential, right? So a little bit of nuanced discussion around some of these topics might actually help us get a little bit of clarity on our aim.
So I definitely agree on the data point, but I actually have a very different view on this topic. My answer is no. There's no specific industry, there's no specific vertical that's going to be impacted or affected more than the other. I think this is foundational to the point that it's going to be transformative in every vertical, in every industry that robots are going to show up. And the reason I say that is because the models we have today are not going to be the models we have tomorrow. And right now we're talking about single large language models, ChatGPT 4, ChatGPT 3.5. We're already seeing large multimodal models. We're already seeing ways to ground those models. We're already seeing ways to offer context through semantic kernels, through semantic skills. And As that ISV ecosystem gets better and better, as the skills get created for domain-specific knowledge, whether you're in a warehouse or whether you're doing inspections of electrical lines, the scenario where you can bring context-relevant information to the foundational model and then connect that with not just translations that the foundational model can do from domain to domain, but also across multiple different modal models. A lot of the AI, specifically for perception, for understanding your environment, for understanding the data that's coming from your environment, and eventually, as you're both talking about, being able to do manipulation back into the environment, that's just going to get better and better. And so as has been shown previously, where there's an ISV ecosystem, there will be a growth acceleration in that ecosystem. And this is the time where software is coming to robotics in a way where that ecosystem is going to be a flywheel.
Great perspective. Slightly sort of going deeper on that question, you talked a little bit about the semantic kernel. You talked a little bit about one layer above these language models or LLMs or multimodal models. Like for a second, let's believe that there's going to be many of these. And we can debate it all day long whether that's one or many, but let's just go with the fact that there are going to be many. Is there going to be one sort of layer to manage them all? Is there going to be multiple of those? Is everybody going to build their own? Like, what's your perspective on that? And as a robotics programmer or roboticist, like, what would make life easier? Is it coming together of all of these things, or is it almost like a single API to manage it all?
Did you mind if I go first? So robotics is nothing more than system science at the end of the day. It's cross-discipline engineering and across multiple different expertise. And the answer to your question is that it just depends at which lens, at which altitude you're looking at. You may be looking at multiple different systems coming together as one system. You may look at each individual system as their own system. And so the different models, they'll eventually be, even if there are different models, they'll be talking with each other. They'll be interacting with each other. And then when you look at it at the higher level, it's just one system. So that's the way I look at it.
Yeah, I will start with the previous question that I didn't answer. And I will say that I agree with both of them. Again, I don't
There's
want
no
to disagree.
disagreement on this
I
panel.
don't-
What
I
kind of
don't- I
panel
don't
is
want to
this?
disagree at all. Did you ask Peter Abil at Berkeley? Who did you ask? Abil?
I asked Jitendra.
Okay. Did you ask Goldberg?
I spoke with him. Yes,
Ken Goldberg is the right guy for manipulation
Yeah.
at Berkeley.
Yeah.
But anyway, let's go back to manipulation, grasping manipulation, data collection, everything. Trajectories of a drone, they are simple. They are X, Y, Z. Okay, you may have also the rotations. Okay. Grasping and manipulation, you have all of these for every finger, and you have friction, you have compliance, you have slipping, you have rolling. We're talking about a nightmare.
Yeah, and feasibility as well. Right?
For this, we need data. The trajectories of the drones, they unlock the potential for cool papers. But this is what we need to do in robotics. We need to move away from cool papers. We need to bring robotics to the houses. And in order to bring them to the houses, we need to enable these capabilities. And these capabilities, they unlock multi-billion, maybe trillion-dollar markets together. All the work that you are all doing, if we have dexterous manipulation, oh my God.
Now you sound like all the VCs who try to make me work on dexterous manipulation and decide not to.
No. I think that we lack the data. This is my problem.
No, yeah. So I am in agreement with you that this is a very hard problem, and maybe that's the reason, one of the reasons that I'm not tackling those. But again, the point of view that you're also providing is a very Western Hemisphere point of view, right? If the kind of utility drones and things that transport can provide in country where I come from in India, the impact is way more than a dexterous manipulation that can package thing. There are 1.4 billion people that can do that thing. So again, this trade-off between value and what's an important, I think it's a contextual thing, right? For me, I think that's a very, very important problem to be solved that can actually change lives. Whereas I understand that this is also an important problem and it can unlock trillions of dollars in in Western markets as well. One of the things with again as a robotics, like we need to take a little bit nuanced perspective, specifically when we think about availability of like technology as it unlocks the potential. Manipulation, navigation, on an algorithm, you can probably write the same algorithms, but again, the ability to collect data, the ability to actually even have robots. There are probably, 100,000 flying robots, but how many arms there are, for instance? I mean, you have those kinds of discrepancies as well that show up as well. So again, we can have conversation all day long about generative AI as a robotic field, but you got to get nuanced.
I completely agree. Can I say something? So your point is that we don't have enough arms to collect enough data, right? But we don't need arms to collect data. We don't need arms. We need humans.
Yeah, I'm going to keep us moving along because we could argue all day long about dexterity versus drones, and I think we've got a passionate group of panelists. But let's open up to the audience and see if there's any questions. I got a series of questions, but let's make this a little bit interactive and see if anybody has any questions for the group. There's one back there. Please go ahead.
Can you guys talk a little bit about generative AI and synthetic data for robotics?
Who wants to take that one?
Well, I can take that one. So years ago, when we started the aerial robotic work, when I was part of Microsoft Research, I mean, I told you about my experience, and that led to this thing called AirSim. It was one of the first open source project that tried to imitate the AI pipeline in robots. So there have been simulators since the advent of computing. And even if you go and look for simulation in robots, you have a bunch of offering. But very few of those simulators actually simulate the AI pipeline. And what do I mean by that? It's you are simulating the data generation process, the sensing process, so all the sensors, and even the compute as you are making decisions through your AI pipeline, the entire thing, right? And I am a strong believer that synthetic data is going to get us to the foundation model for robots, but then you still have some of the shortcomings, right? It's still not real data. There is still aspects that we cannot capture in simulations, of aspects of physics. So for instance, trying to simulate LiDAR sensor or radars, there have been several PhD theses that have been written on those topics and so forth. So there always be a little bit of a discrepancy. So our roadmap has been to realize that there will always be gap with simulated data. But nonetheless, simulation is going to constitute at least 90% of your training data for foundation models. And your 10% data is going to come from real world missions. And of course, the challenge is how do we get those data, how do we curate those data, and then use it in a manner that complements the weaknesses that we have from the simulation data. So I don't know if it gives you a sense, but I'm giving you my perspective. Strong believer that simulation is the way to go, specifically for AI in robots.
I'd like to thank Sunava for the question back there. So thank you. I view it as a giant flywheel. There's no question that synthetic data has been and is going to help robotics in a significant flywheel way. It'll start at going with what Tim showed with the 9-box, starting in the lower left-hand corner and helping with how motors work and how motors work with other motors and with linkages and joints, and then it'll go up the stack to how the entire robot works together to make synthetic data better and better, to apply AI at each of the different layers at the lowest level of the robot. And then when you have multiple robots working together, then the simulated data is going to help based on the environment and how those robots interact with each other. And then when you go to fleets of federations of fleets of robots, again, the environment and the interaction models is going to be fed by synthetic data. So there's no question that synthetics are going to be an important part of how we get to better and better generative AI models. But the important thing is that those can't just happen at one layer. This is a systems of systems problem, and it's got to go all the way down to each composite system, all the way to the lowest form. And that might mean that we need to rethink how we do individual motors, individual servos, individual electrical sensors. A good example of this using software is that all of us use the JPEG format. JPEG format and the GIF format, for that matter, those were both optimized for extremely low bandwidth communication lines, and the way that they do quantization, the way that they do compression, you go deep into that code, they've made a lot of assumptions about the systems that they were being run on at the time. You look at new modern imaging systems, imaging formats, they don't make those same assumptions. They do much better. It's because somebody went back to 15 or 20-year-old standards and actually made the changes to make those better and introduce new ones. The exact same thing is going to happen, and it's going to be because of synthetic data.
Great question. Great. Where are you? Very nice. They are a very good starting point. For dexterous manipulation, if you believe that synthetic data can do the job, it's like you believe in unicorns or you believe in fairy tales. I had a meeting with NVIDIA. And we participated in the same workshop, academic conference. Some people came from NVIDIA, discussing about the simulation that they do, state-of-the-art simulation. It took them 3 years to simulate fastening of screws. Can we afford this? Can we wait, I don't know how many years in order to do what we want to do with simulation? We can go out there and collect the data. We can do it. And in the process, we can better understand how we do dexterous manipulation.
Or we can have arms with a wrench, and we can just screw it right away.
Yes. One approach to collect data is with arms. I tell you, please go to Universal Robots and tell Universal Robots, I want to buy tomorrow 10,000 robots. And please send me an email with the estimated time of delivery, because I want to laugh.
Yeah. So, a question that we should ask is that, sure, it's a great academic exercise to think about having fingers to a, screw a nut into a, into a hole, or are there better tools if you are trying to be pragmatic? Like, is it an academic question? Or, if you right now want to have an assembly line that screws nuts, I think we do have a solution already. Why do we bother with going via dexterous manipulation? Again, I'm just trying to be a little bit.
Yeah, I think there's a breakout session on dexterous manipulation versus not. That's gonna follow up. We're gonna start that at 7 and over some beer. Yeah. I saw another question out there. There was a hand raised, and I want to make sure we address that. Yeah, please go ahead. It's not on dexterous manipulation, right? So I want to make sure I understand and repeat the question, get it right. Like, is your question more around the lines of like, hey, are we going to see more on like individual robot applications where they control one robot versus a collection of robots, given the fact that you need interconnectivity and network? Is that right? Did I hear it right?
Yeah, like given that Gen AI needs cloud connection and all that.
Yeah. So in my experience, all the designs that we have encountered and have been studying, they have edge component to it. So you do have maybe some foundation models, but then you fine tune it and you distill, and you have a neural network that you'll eventually, it's NVIDIA Jetson or Xavier, and then you'll fly your drones with it. I do believe that there are some promising developments happening. So specifically, if you're following the development of 6G communication, so those discussions are already happening in a decade or so time frame. So I was part of a working group looking into 6G communication. They are looking at robotics applications, where you are trying to provide SLAs, service level guarantees for data communications. And that will unleash a new family of models that can be deployed on robots. But it's still few years out. Right now, currently, all the models, in my experience, have been on the edge. But I am hopeful that in a decade time, you are very likely going to see robots that are connected to the cloud with the service level guarantees that are unheard of right now.
Ashish, can I take this question further a little bit? I think one of the things that we've talked about the last time is, so what's changed in the last 3 months and what has gotten easier? Like we talked a lot about taking the friction out of the system, but in the last 3-4 months, if I'm sort of building a robotic system, what has changed for me? Am I saving time? Am I saving money? Is perf better? Is quality better? And question to all the panelists, but how should I think about it if I'm building a new robotic system?
I think what's changed is similar to how software evolved when when it went open source, when more folks were contributing to individual repos and then composing those on top of each other to build bigger collections of repos on top of repos. The same thing is happening here. Every week I come in, I pull in the most recent semantic kernel repro, and it's changed. It is drastically changing. There's more skills available. There's more skills available for Microsoft. There's more third-party skills showing up, and the ability to compose those skills and orchestrate those skills. And the key there is, unlike having any combination of skills that you're going to put together, you could have written an a priori program that would have done that. The key here is that what's gotten really good is the orchestration and the ability for the generative AI to choose which of those skills is going to be used contextually for the problem you put in front of it. That's getting better and better. And it's getting better and better because the skills are getting better and better. And at the same time, those that are building LLMs, both on the edge as well as in the cloud, it becomes a virtuous cycle. To the specific of the question, if you want one robot to be empowered with and enlightened with generative AI, it can happen on the edge. It can happen on the robot. If you want multiple robots to coordinate with each other, again, that can happen on the edge. But then what you're doing is you're doing an orchestration problem locally. You're not getting the benefit of all of the learning, all the generative work, all the virtuous cycle that's happening in that composition and composability of all of those skills. And so I don't think that I think it's a false dichotomy to say, is this going to be a cloud-only problem or an edge-only problem? Both aspects will be there, because when you talk about robots, you're always talking about interacting with the physical environment. It will always have an edge aspect to it, but the cloud makes it that much more powerful and that much better.
We got time for 2 more questions, so why don't we take one? Go ahead. Sorry, did you have
Can I take this? Can I start? Yeah. Yeah. Thank you. The problem here is that we have, on one side, generative AI and technologies of 2023, and on the other side, programming methods for the robots of the 50s and the 60s. They coexist in industry. If you go to industry, you will see pentants. Try to program a robot with pentant. It takes forever. How you will deploy fast new solutions? We need new methods of transferring skills from humans to robots that will be methods of 2023. When we accomplish this, and we add also dexterous manipulation, then we will be able to do anything that you can imagine. And your imagination will be the final frontier. Okay.
I'm going to take it, answer it in a slightly different and nuanced way, at least from our perspective. I think if you look at the customer, right? I think one thing that they're trying to evaluate very quickly is what's my time to ROI, right? And I think ultimately it comes down to not just the fact that hey, you're going to take more build time or more deploy time or more manage time or resources. I think it's all of the above, right? If you can sort of get it to a mode of like, hey, it's instantly out of the box, ready. You're deploying it faster. Your maintenance and management is not costing you much. Your time to ROI is faster. And I think that's the kind of holy grail. I mean, look, none of these things are easy, but at least from our perspective, from an investor standpoint, as we're looking at it, one of the things we hear consistently from customers is it going to pay off in a month? Is it 3 months? Is it 6 months? Or is it 9? And what is my fully burdened cost, right? And then there's a complexity of like CapEx versus OpEx budget, right? Like, am I buying the hardware? Am I, sort of you purchasing it and managing it in a software as a service kind of manner, et cetera? So there's a lot of nuances to I think your question, but ultimately it comes down to like how quickly a customer realizes value and what's the lowest sort of cost that they got to keep on paying.
So I want to actually build off of that. The thing that I've seen with customers and partners and with my own learning journey and with our team's learning journey is the first place where it's not necessarily free, but it's very low friction and low cost is put the robots aside for a second, okay? How can you change your own workflows at work to become 10% more efficient, 20% more efficient with ChatGPT? Tim asked me to do something that would have usually taken me 3 or 4 days. I can put it to ChatGPT and get a summary of, companies that we're going to be meeting with, et cetera, pretty quickly. And is it perfect? No. Is it accurate enough that we can, move forward and have the right conversations? Absolutely. And, when I write code in a language that I don't necessarily have familiarity with, using Codex, using Copilot for VS Code is another example. And so when I talk to customers and they've had no exposure to ChatGPT at all or any of the large language models, the first place I start is, how can you improve your own workflow? Let's look there. What happens is that brings them over the chasm. That brings them understanding, wow, this is not something that's a fad. This is not a meme. This is a real transformative experience. And for those that understand robotics, that understand the industry, even if they're operating out of knowledge from the 50s, all of a sudden the light bulb goes off when you show them that this can actually be applied to the machines, the problems, and the business opportunities that they see in front of them. And it slowly works up from there, where the next thing you know, they're trying JSON file formats to go to their robots, which they're able to deploy and actually see a flight path get generated.
Can I say something? Sorry, I want to clarify this. They cannot generate files that can be deployed on robots. Let's not make this mistake. LLMs, currently, they are not able to do that for industry. They are able to do that for academic papers. If you want to discuss this further, come after the panel and find me. We can discuss it in detail and technically. We need data in order for the LLMs to do this, and we need LLMs that will have also actions inside. Actions that will be able to generate paths, that will be able to generate complex trajectories. I don't want to hear, I hear all the time, and it is a little bit irritating. I hear LLMs will do this, LLMs will do that, LLMs will start programming robots. Don't believe that. It's not feasible. LLMs are not there yet. Where are we recording this? Come and find me with the recording and tell me that I was saying these things today.
Let me ask you a question.
Yeah.
Okay. Can a robot, if you feed it a set of waypoints, be able to navigate in a somewhat structured environment?
2D, definitely, yeah.
Okay.
Easy.
So, okay. Can a LLM generate a JSON file that has a set of waypoints for the robot to navigate?
2D.
Yeah.
Yeah. For industry, this is nothing. I said industry.
It depends which industry.
All the industries, all the industry factories out there that do stuff.
So if you're talking about industrial manufacturing, perhaps you're correct.
Yeah, of course.
But that's not the only industry. That's my point.
Yeah, okay. There are small parts of industry that can benefit from LLMs. Yeah, I agree.
There are small parts of industry that can't benefit from LLMs.
No, I don't want. Okay. This panel is a little bit heated right now. I agree with you, and I agree also with you. My
I didn't
point.
say anything.
My only point here is that we need to clarify where we disagree and go and ride this awesome wave of generative AI. We cannot ride it if we don't have the data. This is my point, my take-home message.
I'm getting a little worried that we need an LLM to resolve conflict, but that's a different conversation. We'll take one more question before we sort of break. I saw another couple of hands, but maybe one last question from the crowd. Yeah, please go ahead. Just want to repeat the question. The question was, do you think the bottleneck is in the planning of the robotic system or the low-level code? Did I hear you right? Okay, who wants to take this?
Yeah, I mean, I'll say it's, again, nuanced. If you talk about drones, I consider control problems for most of the drone form factors solved. They can hover in 50 knots gusting winds, right? I don't want to even compete with 200 years of control theory there. And sure, planning is a very sweet spot to be. But on the hand, dexterous manipulation, probably you want to talk about that.
And you gave me two options. I will take the third. The bottleneck is the data. The other two, we have a control theory. I don't know how many years of experience in control theory. Path planning, great methods. Data, zero.
There's absolutely bottlenecks in both. There's no need to create the false dichotomy. They're both there. They both will be there. The important thing is identifying where those bottlenecks are stoppers and where they can be worked through to get to the next step. And the learning and the knowledge that you take from that will then help the bottlenecks in the other areas. Again, it goes to, it's a system of systems and a virtuous cycle of those getting better and better.
Great. Hey, I want to thank all of you to bring your very spirited and experienced views onto this panel. And thanks to all of you for joining as well. You guys, if you have any follow-up questions on certain topics, please, you can find these guys over here. But let's take a small 10-minute break, and we'll be back with the rest of the show.
As far as the second half of this evening, one of the things we wanted to do in creating the Northwest Robotics Alliance was connect the ecosystem, given that we have a lot of diversity in the state, all the way from the ports to ag, and we have a lot of different things happening in robotics. But a lot of the alliances that exist nationally have a university as well. And that's where UW has a significant presence. One of the things we're so impressed with is what's happened with FIRST, and many of you started in FIRST. So today, we invited Emer Dooley from UW and the Creative Destruction Lab to kind of share more of what they're doing and how folks in the robotics community can get involved. And then also Lila Mowat from the FIRST Washington organization to share more about her organization. Thereafter, we're going to move into 4 lightning rounds. And what's fun about the lightning rounds is they're timed. So we are going to have a timer. And so that makes it kind of fun. They're 5 minutes each. And then we'll finish up with James closes us out. And I think we have a light dinner being served after that. I think it's just pizza and salad and some fruit and stuff. But there's some drinks over there. And you're open to stay as long as you want for the networking thereafter. So with that, Emer, we'll kick it over to you. Oh, Lila's going first. Lila, go ahead.
I'm just going by the cues, Jeff. Thank you. I wanted to first thank Jeff and James and the crew here at Fresh for inviting us. We're thrilled to be here. And Ashish, I welcome you to move your operations over to Central Washington, where I assure you we have more than 90 days of sunshine a year. Just throwing it out there. Good evening, everyone. My name is Lila Mowat. I am the Director of Development and Community Relations for First Washington. We are a statewide after-school STEM organization. I'm based in Yakima, Washington, which is why I was giving Ashish a little bit of grief there. but we have been in operation since 2001, and I'm thrilled to be able to give you all a little bit of an overview of who we are and what we do and why we are the future, literally, of what everyone is discussing in this room today. So our mission is to support and inspire diverse young people to be involved in team-based robotics activity, and we are supported by a knowledgeable, and I would also add a very, very dedicated volunteer community. We cannot do what we do without the thousands of volunteers that help day in and day out, and that's with individual teams, that's at our competitions, and that's with a lot of the activities that our teams are doing. So thank you to those of you in the room who have been volunteers, and to those of you in the room who would consider becoming a volunteer in the future. So as you can see, we have 4 distinct programs. We have our first LEGO League, Explore, which is for the youngest kids from, that could start in pre-K, goes to about 2nd grade. And we also have First LEGO League Challenge, which covers the rest of the elementary school ages. Again, it's very introductory concepts of robotics using Legos. And the kids also spend half of the time with a research project. So just kind of getting their feet wet, getting them exposed to the idea of robotics, and also being on a team. The next program is First Tech Challenge. That's primarily a middle school program, but we also have a lot of high schools that are involved in First Tech Challenge. It's a smaller robot, it's about 40 pounds, fits in an 18 by 18 box, and they compete on a 12 by 12 field. So this is the next level up. The kids are competing depending on whatever the theme is every year, and they're also kicking it up to the next level in terms of fundraising. They have to be involved in their community. There's a program that or a problem they will pick in their community to solve. So it's more than just robotics, it's business planning, it's managing a budget, it's public speaking. And of course, our flagship program is FRC, or the First Robotics Competition. That's probably the program many of you are most familiar with. It's the big robots, it's the big exciting competition. This is our high school program. Again, the kids are involved in fundraising. They have to get involved when we go down to Olympia and we meet with our legislators. So they're learning about advocacy. And they're also learning what we call our core values. And one of them is gracious professionalism. Because we want these kids to understand that in life, you need to be competitive. Everyone is not going to be a winner, but there are going to be many opportunities and situations where you perhaps will be a coworker, you will be a classmate or an employee of someone you have either competed against at a First Robotics competition or someone you have met. So it's not uncommon to have teams from various communities. Someone's robot will break down, they need a tool, they're missing a part, and another team from another community will jump in, help out, and that's the gracious professionalism. So just a little bit more about the progression of programs. I think it's pretty self-explanatory. Building blocks, starting with Lego and the Spike Prime Essentials. Again, manipulating and adding our first core values, and then expanding and moving through the programs. I think these pictures are a good representation of what we do. You can see the FLL Challenge and the FLL Explore, very cute. You know, I think oftentimes the kids need a little bit more of a challenge, so they will progressively move on to the FTC program. FTC and FLL have been very popular in communities that we're growing in, which I'll show you in another slide. And of course, FRC, big robots, very exciting. It's amazing what these students can do. It blows my mind. So the why. First Inspires, which is our parent organization, commissioned a study with Brandeis University a few years ago to really do a deep dive and look at the data of our graduates and what's happening with the first students. 86% of female first alumni and 91% of male first alumni declare a STEM major. 59% of female first alumni declaring a major in computer science or engineering versus 12% of comparison students. And I would assume that this percentage is probably higher because the study is from a few years ago. 60% of first alumni who are currently employed in STEM fields. I know for a fact that there are first alumni working here at Fresh Consulting. There are other companies that we know for a fact will hire first students solely based on the fact that they have been on a first team. And another project we're working on in the workforce development world is this area of micro-credentialing. We're involved in some conversations and some working groups with the National Governors Association to figure out how can we credentialize a student's experience on a FIRST robotics team so it can become part of this, what they're calling an electronic learning record, that a student can take with them to another state, to another job, so there's less constraints when it comes to just having a college degree to getting your foot into the door. So as I spoke about our growth, First Washington is traditionally very much a Western Washington focused organization, which is just by nature of the concentration of professionals and schools. We've been very fortunate to have expanded and grown over the past 2 years in Eastern Washington. And we have also done a deep dive in our data, and we've seen that our programs grew by 1,010% in Benton, Franklin, Spokane, and Yakima counties. Many of these places had 0 teams pre-COVID. And in the case in Spokane County, there were many teams that were pre-COVID that we lost, unfortunately. We're growing partnerships with tribal partners. We're working with ESDs, rural districts. I mean, there is a really, really deep and big need for robotics and STEM in communities in Eastern Washington where there's literally nothing going on and there's nothing for these kids to do. So for us to come into the communities, come into the schools and offer them funding and offer them a coordinated and a robotics program, it's life-changing for these kids. And of course, we partner with community organizations, Boys and Girls Clubs, communities and schools, Girl Scouts, 4-H clubs, and of course, we like to connect mentors and volunteers in industry with the students. We have a massive network of graduates and alumni who may be transitioning careers or looking for something new. And of course, we partner with our friends in higher education, all of the U's that are mentioned here. And I would just like to close by inviting all of you to join us. We can't make this growth possible without support, without volunteers, without mentors. And as I mentioned before, the future of the robotics industry is with these children. And also, I'll put a little plug out there for those of you in the corporate world. If you're looking for more females and more diversity in your future workforce, you have to get these kids young. Studies have shown if you don't reach a young woman by 5th grade, chances are she's probably not going to consider robotics as a field of interest. So we're the right organization at the right time to invest in, to get involved with, because we will create this pipeline of your future workforce. So thank you very much. And if anyone wants to chat more, you can find me afterwards.
Okay, so anybody who knows me knows I have a terrible time standing still. So standing near this microphone, we have a bunch of our mentors in the room. I'm Emer Dooley. I run a thing at the University of Washington called Creative Destruction Lab, which is a mentoring program for super deep tech startups. And the reason I'm here tonight, I can advance them, yeah. So CDL stands for Creative Destruction Lab. But before I start, I want to say a huge thanks to Lila and FIRST Robotics. It's an incredible organization. And in fact, my partner isn't here tonight because he's on the board of FIRST Robotics and they're having a board meeting right now. We're huge donors. We're not huge donors. We're donors. We're supporters. It's just the most incredible organization. So get involved. Anyway, Creative Destruction Lab. So what we do is, at the University of Washington, it's a joint program between Computer Science, College of Engineering, CoMotion, which is our tech transfer office, and the business school, Foster Business School. And what it is, it's a mentoring program for super deep tech startups. And why it matters to anybody here in a robotics audience is one of the areas, so we take 2 cohorts every year. One is computing to change the future of health and medicine, but the other one is computing to change the future of United States or North American manufacturing. One of the things we realized during COVID is that, with our supply chain problems, we got to reshore, some of the very strategic things. And, I've read Chip War, some of it's not reshoreable. But we're looking at basically accelerating companies that are using systems, software, and processes to change the way manufacturing is done in North America. And so front, right, and center of that are robotics, right? So it's anything, if you talk to any of the big manufacturing companies, one of the biggest problems they have is getting workforce. So workforce enhancement, IoT, robotics automation, CNC software automation, those are the kinds of companies we're looking for. This year, Acumino, the manipulative, what was the expression I did? Dexterous. I'm sure everybody in the room can recite it after tonight. Except me. I'm slow on the uptake. But they were one of our portfolio companies this year. Another one of our portfolio companies was a robotics company that just closed a $4 million round 2 weeks ago. It hasn't been announced yet, so we won't talk about it. But super cool example. We've got a couple of our mentors in the audience tonight. I'm super proud of that. But this company came into Creative Destruction Lab last year. So what we do, it's a global organization. It's at 12 of the top universities around the world. What we measure ourselves is what is the equity value that's created in the companies that have come through our program. So the reason I bring up one of the robotics companies that was part of our program this year, they came into us, they've been around for 10 years, had multiple lives before they met our mentors. And then coming into the program over the course of 4 sessions, we operate on an academic year, so we're actually going through recruiting companies right now. We'll start in October. Over 4 sessions in an academic year, we bring these companies together with our mentors, and they only work on 3 things. What are the 3 objectives this company needs to achieve over the next 8 weeks to move the needle where they need to be by the end of the year? And so the idea is that you've got brilliant startup founders, as you kind of saw some of them on of the 5 million things that they need to do over the next 8 weeks. It's hard to figure out what are the 3 that are going to move the needle. And so CDL's founding premise is we bring people into the room who have that judgment. So we don't have service providers in general. We don't have investors as part of our mentor group. These are people who've created, built, and exited companies. So for instance, in the manufacturing stream, I'll show you just some of our mentors, some are in the room today, like Hans Paul, who created an IoT company that he sold to GE. You know, he's been there, done that. We've got Rob Meyerson, who was the founding CEO of Blue Origin. He took Blue Origin from 10 to 1,500 people. So there's real expertise in the room. And what happens on a session day? I'll follow my slides. You know, somehow I had to ask Kurt what they were. Anyway, I said we're at 12 universities, now 13 around the world. We just announced Melbourne. So at the University of Washington, for the first time ever this year, we had a manufacturing cohort. So we interviewed, we had about 60, 70 companies apply. We interview about 30, 35. And then we admit a cohort of 20 companies. Now, a couple of things that set us apart from other mentoring programs. First of all, it's a university program. We don't take any equity. We don't charge any fees for any of these companies. So we like to think that because of that, we get a pretty high caliber company into the cohort because they don't have to give anything up. The other thing is the caliber of the mentors is pretty spectacular. These are people, as I said, who've created and built and exited companies before, or they're representatives from some of the biggest manufacturing companies around here who may pilot. So one of our companies last year got a pilot with Nestle. We've got Rakri Srinivasanam from Nestle Manufacturing. The first time I talked to him, I said, well, I didn't know, Nestle is the biggest food company in the world, that they have 400 plants around the world, and the kinds of manufacturing problems they have, in goodness knows where. They just slap a HoloLens onto somebody and diagnose it remotely from, Minnesota. It's just fascinating, the things we've found out. But anyway, in the robotics thing, so this year we had multiple robotics companies. What we're looking for are robotics companies that are really tackling things that are going to change the way manufacturing in the United States works. And that can be manufacturing, very, very broadly. Everything from the Packards and the Boeings and the Blue Origins and the SpaceXs, to lots of other different kinds. Macy, who runs my team, is actually in the audience too. So there's 2 of us if you want to talk to us about this. Our inaugural cohort this year, as I said, had 2 robotics companies, but we also have things like, as I said, like autonomous CNC. There was a very cool autonomous CNC software company, a company that wrote software for super complex additive manufacturing. This company here, female CEO, she was a mathematician. What they had was complex software for additive manufacturing. We thought they were going to sell into somebody like Packard and Boeing. It turns out they landed a big deal with Adidas that were trying to get a very structurally sound sole for a shoe using a minimum amount of material, and they had the software to do it. So those are the kinds of companies. One of my asks is, right now we're recruiting companies for robotics companies and others for manufacturing. If there's anybody here who's a deeply technical person who is interested in doing technical due diligence on these companies, just come talk to me. We have the coolest people involved. We're seeing the most amazing startups, and it would be fun to talk to you about it. Some of the mentors that we have, as I said, people who've created and built and exited these kinds of companies. Interesting one is Natalia Bailey. She created a company called Axion. So she started this company, ran it for 10 years. And I sat in a room with her and I said, just tell me, what's your area of expertise? And she said, ion propulsion. So what she built was a propulsion company for small spacecraft. Very interesting. And so these are some of the kinds of people. Nathan Kuntz started a satellite company. Rob Myerson, as I said. Patricia Hume has a software company for manufacturing facilities around training videos and parts. It's a very, very cool group of people. And really what we do is, these companies, by the way, so if you want to apply to CDL, you do not have to be associated with the University of Washington in any way, shape, or form. It's open to everybody, because what we get out of it is, first of all, we get really cool people like you on campus, amazing people like Microsoft as corporate sponsors for this program. And the other thing we get is, part of this program is a group, there's a class of STEM PhD students, MBAs, and some undergrads that follow this program all the way through the year. And what they get to see is, on session days, when our mentors talk to these companies, it happens in sort of two sections. On the morning, we run through small sessions where companies meet one-on-one, one or two with the mentors. My team has prepared investment documents, so all the mentors come prepped and ready to ask questions. And what they do is, in the afternoon then, we go into this large room session where all the companies, all the mentors, and the class of students are sitting there, and we have a moderated discussion about every single company. I can see the Acumino people going, yeah, it's horrible. So the mentor stands, or the entrepreneur stands in front of the room. She's got her 3 objectives on the screen behind her, and then one of the mentors will say, okay, objective 1 is good, 2 is good, 3, I don't know what she's thinking. Why on earth would she try and do this over the next 8 weeks? And that's where the discussion begins. But the cool thing that happens is, entrepreneurs leave the room at the end of the day. They're a participant in this discussion. They leave the room at the end of the day with a peer-reviewed set of objectives, to be a university about it. But the other thing that happens then at the end of the day, all the entrepreneurs leave the room, and that's where we have another discussion with the mentors, and we go through company by company, and this is where you weren't, and that's where we'll discuss, okay, we'll ask the mentors in the room to raise their hand to pledge to spend at least 4 hours with this company over the next 8 weeks to get to those objectives, to help them. And that's where we get people with pilots in companies. That's where we help them get access to funding. And we just help them sometimes with their business plan. But if there's a company that no mentor wants to work with, we have a discussion about it to get feedback for the entrepreneur, but then they're not invited back. And we have a mandatory cut of one company at each session. So as you saw, we had 8 companies out of 20 graduate from the program this year. This is our first year of manufacturing. It's only our second year of CDL Seattle, but the companies that graduated from our first cohort have already raised $30 million. And as I said, one of our robotics companies just closed $4 million last week. Metafold, the 3D software company, closed a $2.3 million round while they were in the program. Anyway, that's it. If you're interested in this at all, if you know people who are interested, we're really interested in finding female mentors, especially. So that's, please come talk to us and support First Robotics.
All right. Look forward to more of that, where we're introducing important members of the ecosystem for the Northwest robotics scene. It's great to hear more. From here, we're going to go to the lightning round. So we want to invite Jason Kelly to come up from Fremont Robotics, Steve Yin from Fresh Consulting, Patrick Jarvis from Acumino, and then Mihai from Dexman. If you guys want to come up and just kind of be queued up, we're going to do the 5-minute sequences. And I think, Jason, you're starting.
Yeah, I'll start.
Awesome.
Yeah, let's just not sit on these seats so no one gets blocked.
Okay, you got it.
Screens, but come on up. Yeah, thank you.
This is the clicker?
That's it.
All right.
And here's the alarm over here for your cue, okay?
All right.
This adds the pressure.
5 minutes starting now. Cool. Let's go. Well, thanks everyone for coming. Thanks to the Northwest Robotics Alliance for doing the second meeting, setting up such a great event. I'm Jason Kelly. I'm CEO of Fremont Robotics. We're a local company focused on systems development and deployment of robots and robot solutions, focused on the industrial sector, customers like plant managers in oil and gas and energy and large facility management. We've all heard so much about how ChatGPT might take our jobs. We probably all take it with a grain of salt, but it's been a classic worry out in industry ever since the first robot came onto a factory floor. But we spent some time with customers like plant managers at a gas plant, a big facility manager at a college campus, and several others, and not one of them has been talking about reducing staff or bringing in robots to save on costs by reducing their human staffing. They're all talking about how can I do more with the people I have? How can I deal with this labor shortage? How can I deal with the fact that the people who can do physical work on my facility are aging out and I don't have a great job for them to develop into? And that's what I see with the groundbreaking opportunity with GenAI and the intersection with robotics is actually turning into here. So we've been working in utilities and oil and gas and manufacturing, and there's a lot of, people see the opportunity, but they also see, like someone said earlier, a really long road to getting ROI out of it. A spot robot dog is really expensive, and it's hard to get budget approval for something like that. But we spent some time, like Dan said, just learning how we can learn how to use these tools, where they help, where they don't, where it's worth the investment. And just wanted to share today in like about 5 minutes, and I've used half of it already, on how that's working out. So we've seen where ChatGPT and GenAI can be actually extremely useful to this audience in the classic use cases of it: generating content, summarizing material, editing data, extracting information. But what's emerging is the ability to actually use and understand how to use external tools like commanding a drone, commanding a ground robot, with the end goal of actually understanding and controlling the physical world without having to be out there. So we'll just go through each one of these quickly and talk about what we've seen out with customers, with prospects in the wild. Like Tim said, generative AI is really good at generating content. And let's take a really broad view of content. Yes, it can definitely generate that JSON file that the panel talked about. And what amazed us with experimenting with this out in some field trials was if you give the model context about the environment, about the fleet of robots, and about the jobs to be done, it will actually generate pretty reliable instructions. You can tell a ground robot, go patrol the facility, and that's it. It'll understand. The model will convert that into a JSON file, if you will, that will set it out and patrol that facility. We've seen that in action. What's even better is we can create these fleets of robots, these federated fleets of robots, because the model can understand context about what are the capabilities of this robot. Is it an aerial platform? Is it a ground platform? We've experimented with just feeding in the specs, the spec sheet for a bunch of different robots, telling it what sensors are on board, and then saying, I need to check this tank farm for hotspots or heat anomalies. And pretty reliably, GPT-4 will pick the right robot, the right path, the right job, and send it out there. All we need is the high-level control library that makes it happen. We've also been generating data at a higher level, generating test worlds that we can use for getting synthetic data, and even using it with customers to walk onto a facility and be able to type a few prompts into a model and get a gazebo simulation that really shows the facility, shows what they need to know about robots. Here's an example I've seen about generating power inspection robot worlds. That is a fantastic slide, and oh, it doesn't show up here. So this is the bread and butter of using GPT, and like someone said on the panel, we're introducing people to the power of these models and being able to use it. Most of these people have very stringent reporting and compliance requirements that takes up a lot of their day. They are generating reports for their boss, reports for their people, reports for the government, reports for corporate, and it really eases the process to just put a GenAI model in the pipeline for doing that. You can describe the characteristics of the report you want, and all of a sudden a customer has saved 5 hours a week just by doing that. And what this is doing is it's really reducing the time to ROI that we think we can deliver. And I'm done. So we've seen some challenges in all of this, and a couple of them are just how non-deterministic the model is when we put ChatGPT into play, and it does tend to hallucinate other data. We had a drone at a trial where, for some reason, the model inserted a minus sign in front of a lat-long coordinate and sent the drone to the southern hemisphere. We caught it in time. But one of the big things is we have to build these safety systems and these constraints around it to keep building on how these models are coming together. And there's some quite complex architectures emerging. This is from a friend of mine at Superwise. And I'm really interested in just working with this community, learning about what parts of this are foundational, what parts are industry specific or application specific, and knowing what people's working on and what we have to build ourselves. So thanks for listening.
Guess it's my turn. Okay, I'm Steve Ying, a principal software engineer here. Are you starting the time? Okay, all right. But first of all, I'd like to thank Kurt for putting this picture here, because this looks really like 30 years ago for me. So I did mention this to my wife. She said, just go with that. So we already see like the generative AI can help our life. I mean, happier wife, easier me. So, but what I'm going to talk about next is really about how we can make our life easier for using the robots. Here, as a robotics team member, I mean, the whole team, including the whole Fresh, is working really hard to deal with all kinds of robots, like the Huskies from ClearPath, some other different things. I mean, all weird, even including robotic arms. So we spend quite much time to figure out the engineering challenges. But on the other hand, we really like to make the robot to be easier for people to use. So this is where the generative AI comes into the picture. And we are having this hypothesis. Maybe the generative AI can help to transform from the unstructured data, such as our voice and natural languages, into the structured data, which is the engineer's favorite to work with. So that's the principle and hypothesis we have. So based on that hypothesis, we went ahead to conduct a small hackathon, which we use a toy bot. This is in the center of that. Supposed to be like 8 years old can handle that, but it did take us like two and a half days. 4 people, 8 hands to figure out things from that. So this is the structure we used, the workflow we use for inputting the human voices through the Speechly. This is a speech recognition service. And then translate that into the text, feed into the ChatGPT. This is the LLM model. Then once the ChatGPT figures out the JSON packet to send through, which like Tim already pointed out, everything being transferred into the JSON file. So then we send that through the HTTP API into the bot. The bot handles everything for the like motion, turning, making noise, singing, all those kind of things. But it's a robotic engineering level work. Then we feed back the result through the 11 Labs generative audio feedback into the users. So this is the whole loop, very simple. We like to keep it simple and stupid, to demonstrate the loop can be constructed using this way. And essentially, we are building from the people to this natural language interface, then into the structured data layer for completing the job, for the easier use of the robots. And this is actually
I didn't even know you were there. My name is Elisha. You look like a cool robot. Can you tell me something about yourself?
Heads. Yeah. He's talking to the bot. The bot is thinking while spinning its face.
Hello again, Elisha. Thank you for your kind words. I'm an interactive robot interface designed to assist and bring harmony to humans like you. I was engineered by Fresh Consulting's Robotics and Fresh Labs team. My interactive design experience was created by the great innovation director, Johnny Rodriguez. My technical engineering was led by technical innovation director, Elisha Terada, and talented robotics engineers Steve Yin and Mike Weller built my body. If you have any specific questions or need assistance with anything, feel free to ask.
Yeah, why were you even created in the first place?
I was created as a proof of concept to showcase a seamless and interactive experience. My purpose is to demonstrate the potential of integrating cutting-edge technologies such as ChatGPT and 11 Labs in a robot interface. By understanding human intent and responding with a human-like voice, I aim to bridge the gap between humans and technology.
Hey, Ginny, turn 180 degrees. This is where the motion is controlled by the human voice, yeah. It's taking a little time to think, but it's there. Well, can you do a show off?
Well, can you say goodbye to people watching at Fresh Consulting?
Certainly, Elisha. Goodbye to all the wonderful people watching at Fresh Consulting. Thank you for your time and have a fantastic day.
Well, a short video from the 2.5 days work. And yeah, very primitive, but effective to demonstrate the idea. So there are still a lot of things to be polished, but for us, as we are thinking about it, what next can we do? This is a try, follow, and apply strategy for us to keep tagging the trend with everybody together. And also, technical side, we really want to integrate more full-fledged robotic platforms using this pipeline. Then on the other hand, it's really on the generative AI side, we really want to explore more potentials to handle more complex logic, more like long-term memory conversational capabilities to handle the workflow management, make things easier for the users to use. Essentially like fine-tuning the human-to-robot interaction experience. But I mean, this is all about fun thing to do the work. It's like a beach time, but when we talk about connecting to the business, we really like to bring this into our service offering if possible. Yeah, thank you.
Hi, everyone. First of all, that is not me. Patrick Jarvis, our CEO, sends his regrets he was not able to make it. He asked me to come in and step in and give his presentation for him. I think he just wanted to get out of it. I'm with Acumino. I'm Tom White. I'm the COO, and it might come as a big surprise to you all here that we are very focused on dexterous manipulation. So when it comes to dexterous manipulation, you're seeing it in warehouses and factories quite a bit. But there are other industries like construction and household use cases and hospitals that are suffering from labor gaps, from labor shortages that require but we're not seeing robots there. And why not? Well, it's because the objects that they're manipulating are varied, and the environments that they're in are very dynamic. That means that the approach that you have to train the robots to do that has to be very different. This is where AI comes in. They need to be taught to be adaptive to these different environments and to these objects. That's kind of where our background is. So Patrick, my co-founder, and I have about 25 years of experience in training complex AI systems. We worked with all these companies on the largest AI problems there are out there. We've worked on every major voice recognition system. We worked on the metaverse. We worked on search engines. We worked on vision recognition systems. All these technologies are very, very different from each other. But the thing that they all had in common was the data to train these systems. They all required huge amounts of data, very diverse data, and real-world data. And robotics isn't any different. It needs all this type of data as well. So we started looking at this problem that way about 5 years ago. How do we approach this? How would we approach this if we were in the industry? And really what it came down to is we kind of took these three approaches. We wanted to have teachers of the robots. So we took from the self-driving car industry kind of the idea of, the cars, they drive around cars, they put cameras on the cars, sensors on the cars, and drove them around and collected the data. Well, let's take the same idea. Let's put cameras and sensors on humans and have them do the task. Right? That allows us to take the robot out of the equation. It means that we can start doing things before the robot is even built. We can pre-collect data. It also allows us to capture human strategies. We can put our devices, our interfaces, on people who are experts in their field on the tasks that they're trying to do and learn from them directly. And we also want to be able to transfer 100% the data that they're doing. So what you can see here is a video of somebody using our interfaces and doing the work of loading a tissue sample into a medical machine. Less than 2 minutes later, we reel a robot into there and it duplicates that task. One of the key aspects of it is the interfaces that he's wearing are very light. They're very easily reproducible. We can create thousands of these. We can distribute them around the world or to all the different locations we need to. And they also, the end effectors on them are replaceable. We can put any commercial gripper or end effector on those. That allows us to collect the data directly using the end effector that's going to be on the robot, allows us to transfer that 100%. So it's a full solution that can be easily then collected in mass to be able to create larger AI models. When we compare our approach to the most common alternative, which is teleoperation, we found that even not accounting for the massive scale advantage that we have, we're 20 times faster and 10 times cheaper than those approaches. That means that what can take a year, oh, how'd that happen? What could take a year, almost a year, 45 weeks to do, we can do in 2 weeks. It changes the game completely. This allows us to collect the massive amounts of data that we need to in order to be able to get dexterous manipulation more widespread into wider sets of industries. And finally, 47 seconds, the main problem we're trying to address here, the labor shortage crisis. That's only getting worse. One study says that by 2030, that labor shortage is going to be 85 million people. Annual unrecognized revenues of $8.5 trillion. I mean, these are massive numbers. I mean, these are economy crippling numbers. These are bankrupt nation type numbers. We can't wait to solve this problem. We have to solve this problem now. We need to start getting this data now if we're going to start solving this problem in time to avoid this major crisis. And that is it. 6 seconds. Thank you.
Hello. Have you guys had enough of dexterous manipulation yet? My name is Mihai Jalobianu, and for the last 15 years or so, I've been working on AI for robotics, primarily at Microsoft Research. And earlier this year, I decided this is a great time to start a company focused on AI for dexterous manipulation. So I founded Dexman.ai with a mission to develop dexterity and common sense for general purpose robots in service of human creativity. We want to create a future in which robots become affordable experts that can work side by side with us, providing skilled help, boosting our efficiency, and enabling us to express our creativity in ways that might not have been possible before. No integrators and no programming required. If we succeed in democratizing robotic manipulation this way, the sky is the limit. The market, the untapped portion of the robotic manipulation market, even by conservative estimates, is upwards of $200 billion. So why is this market untapped? Several reasons, but primarily it's a technological limitations, and you've heard about this already several times. The most significant limitation is that with existing methods, most of the tasks above this line are simply not solvable. However, 3 factors are converging to change the tide. First, the hardware is becoming a commodity. In fact, most of the tasks above that line are doable by teleoperating off-the-shelf hardware today. So the hardware is really good enough. Second, end-to-end machine learning methods have demonstrated levels of dexterity unheard of with classical methods and sometimes exceeding human dexterity, as in this beautiful example from OpenAI from about 4 years ago with manipulating a Rubik's Cube. And third, transformers and generative AI are providing a way to scale the performance of models with more data in ways that boost generalization and transfer, zero-shot transfer. The beautiful, and again, a nice example from Google with their RT2 work of just a few weeks back. The missing piece continues to be the ability to efficiently learn new skills, new dexterous skills that can be used across many tasks. When this problem is solved, it will likely have a seismic effect on robotics and society as a whole, and this is exactly what we are focused on, dexterous manipulation. So our key technology is a foundation model that we call the artificial motor cortex, which maps visual and tactile inputs to actions and outcomes, and which we train by interleaving expensive robot experiences with cheap YouTube-style videos of people performing manual tasks. So you can think of AMC as sort of muscle memory. It effectively elevates robot control to a vocabulary of learned skills, and it creates a way to map language and body movements to sequences of such skills. So what emerges is the ability to do in-context learning from language instruction and visual demonstrations without being completely tied to a particular piece of hardware. A key ingredient for training AMC is a coherent learning curriculum. So inspired by the Montessori method, we use objects and settings that provide a simplified versions of adult reality, where the interactions are progressively more difficult and focus primarily on context-rich actions and skills which are impossible to generate in simulation. And this is very effective in reducing the data needs of training. To validate our approach, we're planning to pilot with a major local design studio, a studio that makes immersive and interactive installations and sculptures that manipulate and transform light. One of the critical aspects in making their artwork is the precise placement of light sources, and having a robot that can participate in the process would open up new form factors and new possibilities for the studio. So here's how our timeline looks like. We just started, we're heads down on a proof of concept, and we plan to start our pilot towards the end of the year. What we learned from the pilot will be rolled into AMC1, which the development of which will probably take most of next year. This is not a simple technical problem. It is similar in scope and in ambition to GPT. And so we are all in for the long haul because we truly believe it's going to be similar as a game changer. And if we're successful, our AI will supercharge robotics for years to come and ultimately make life better for everyone. Thank you so much for listening.
See if I can do this. I don't have all this committed to memory, so please excuse the reading. Hi, everyone. Some of you know me, some of you don't. I'm James Dietrich. I'm the Robotics Solutions Director here at Fresh Consulting and one of the co-founders of the Alliance. Firstly, let's just start by giving everyone else another round of applause. To our keynote speaker, to our panelists, to our presenters. This is how we start this community. This is what it's all about. But to cap off the evening, I want to share just a few closing remarks and provide some additional insights on what we're building and where we want to go. I'll begin by saying that the idea for this alliance is not new. Thankfully, there are others who have been operating similar nonprofits around the country that we can emulate and learn from. In my hometown, Mass Robotics has brought together over 400 robotics companies, local universities, STEM programs, and other state and local resources under their mission. In the Bay, Silicon Valley Robotics Org has done the same and is another shining example for us to follow. And most recently in Pennsylvania, the Pittsburgh Robotics Network has been established and has gained a lot of amazing momentum in a short amount of time. All of these organizations offer our region a proven model to build from, and they have an outstanding track record of building strong regional robotics ecosystems that stimulate local economic development, nurture local talent pools, foster greater collaboration and growth with our regional STEM communities and university programs. They attract new investors and incubate new ventures. And most importantly, all of these orgs are accelerating the continued development, commercializations, and scaling of robotics technology, software, hardware, systems, and components. The Northwest Robotics Alliance aims to do the same. We will do the same, but we also want to do more, and we want to find ways to set our program apart from the rest. Judging by the attendance here tonight, the attendance from a couple months ago, and the collective influence that this room has in this region, I would say that we're well on our way to putting the Northwest Robotics Alliance on the map. Behind the scenes, our alliance has already been working closely with these other clusters across the country as part of the recently established U.S. Alliance of Robotic Clusters, or USARC, which is giving all of us an opportunity for greater collaboration, communication on important advocacy issues, policy issues for the U.S. robotics, autonomous, and intelligent systems industry. I didn't want to get into the macro. Amer, you kind of opened the door for it, but some of these initiatives include some really important policies that impact all of us. You mentioned reshoring. The robotics robotics is an essential part of this reshoring story, increasing U.S. economic growth and securing our supply chains. Rolling back changes to the R&D expensing bill in 2022, changes were introduced which significantly reduced the support that businesses gain from investing in innovative technologies. The R&D Coalition is campaigning to reverse these changes and increase tax benefits again to support continued R&D growth. Putting robotics back on the national agenda, in June of last year again, the NSF announced the ending of the National Robotics Initiative 3.0, which over a 12-year period invested $250 million in over 300 pioneering research projects and innovation in robotics. And now that the National Robotics Initiative has ended, USARC and the Northwest Alliance will have a chance to get that back on the national agenda. And again, increased collaboration with IEEE, the Association for Advancing Automation, A3, and other standards and policy orgs is going to be an important part of our mission. So what is our mission? Well, it's much the same. It's to establish a unified purpose, values, and incentives for growing robotics development in our region. Number two is establishing a better operating model and mechanisms for actually giving back to the robotics community at large. This is where I see a huge opportunity. Via open source tools, frameworks, architectures, standards, code libraries, access to shared working spaces, lab equipment, whatever it helps to accelerate this progress, we're going to do it. We want to increase robotics investment and adoption within the region. That's why our partners at Madrona and Cascadia are so important as a part of this. And we want to address a unique industry, environmental, and economic challenges that the Northwest has, where novel robotic solutions can be commercialized for global benefits. So coming out of tonight, we want to solicit more of your involvement. We want your feedback. We want your ideas. And we want to know who's interested in taking leadership roles as we continue to build this organization and drive its strategic direction. We've set up an alliance email for this alias. Yep, right. And this alias will go to me, Jeff Dance, Asim Datar, and Firdaus Bahawala, our current partners and co-founders. We'd also like your involvement in a few subcommittees that we've created to continue to drive the growth. We've got a global standards group. We've got an architecture and developments resources group that will create a centralized hub for open source tools, frameworks, architectures, code libraries that we can all leverage. And then scaling, fundraising, and advisory. We're really quickly nearing a point where we're going to want to go out to the community. We're going to be raising funds for this nonprofit so that we can hire dedicated leadership and start investing in the mission and goals and our objectives. So I encourage any and all of you to please email us if you want to take a part, if you want to get more involved, be a part of these committees, or if you just have ideas for additional committees or initiatives we haven't thought of yet. So to wrap things up, I want to thank you all again for being here tonight. We have an outstanding robotics community in the Northwest, and we're looking forward to uniting us all together under this alliance. We'll be reaching out to everyone again soon with more updates and more events and things to come. And with that, this concludes our programming for this evening. Let's all have some beer, some food, some drinks, network together, and thank you all again for coming. Really appreciate it.